Okay, so for this one, we are doing the 3.3 loaner divider method. So, like you learned in the previous one, you learned about the um, divider chooser method. So, in that particular instance, what you did was you had two people, you had the divider, and then you had the chooser. So, for this one, um, the loaner divider method, this is again continuous. So this is a method if we have more than two players. So more than two people in the particular game we're doing. So we have assigned players. We assign a player to be the divider. We have division. Divider makes three fair shares from the goods. The shares are S1, S2, and S3. Bidding. Choosers identify value of each share to put them in a bid list of fair shares. So fair shares are valued at greater than or equal to 1/3. You might be wondering, why is it greater than or equal to 1/3? The reason it's greater than or it's equal to 1/3 is because when we do this particular instance, what we're looking at is three players. So three players, 1/3 of that is our 1/3 of that is going to end up being our answer for that. So unfair shares are valued at less than 1/3. So anything that's less than 1/3 is an unfair share. So for our distributions, shares are given to players based on the bid list. So there's only three shares, and it's given to them based on the bid list. Okay, so you should be hearing me anyway. Um, I'd really hate to get all the way through this and not be able to see it. Okay, so case one, each chooser can receive a different fair share from the bid list. This is one of the particular cases that can happen. So this is a scenario, a situation that might happen. Optimal distribution. So every player wants to maximize their share of the goods of the booty. Okay. Now, um, that's kind of where we're sitting at here. Now, if you ever get to a point where you're getting lost, remember that the teacher notes are right here. So my notes are underneath, as well as this video that I'm currently doing will be embedded here. So it does take a minute for it to load for whatever reason, but it is there for you. All right. Have you loaded up yet? No. Okay, so here, case one, three siblings, Dale, Cindy, and Claire, are dividing their backyard into three pieces of land. Determine which piece of land each sibling will get. Okay, so when we look at this, analyzing here that share one, Dale values as a third, Cindy values it as 3/5, or excuse me, 35%, and then Claire values that the most at 40%. Dale thinks every piece of land is equal, in his opinion. Cindy likes the first one, doesn't really like 10% of her value there goes to the second one, and 55% of her value goes to the third piece of land. And then Claire likes the first one at 40%. She thinks that's fair, that's greater than 1/3. Thinks 25% for the second piece. She doesn't really care for that one. And 35%, that one she likes, but it's not necessarily her favorite, considering it's not that 40%. So she's okay with that. So when we create that bid list, if we come back down here and see the bid list, Dale's S1, S2, S3, Cindy's S1 and S2, and Claire is S1 and S3. So you might be wondering, what does that mean? Basically, for our bid list, oh, can't do this, it won't embed here. So for our bid list, we do this brackets and we say S1, S2, and S3 because those are the ones that Dale, oh, sorry, I'm on a different case. Those are the ones that Dale considers to be fair. Okay, he likes that those are fair. I'm going to come down. I'm going to come down here to, I don't think I can move that. So I'm going to come down here to the one that's already filled out. See, in his bid list, and you just put these in that table, these are the ones to Dale that are fair. All three pieces of land are fair to him. For Cindy, only the first and the third are fair. And for Claire, the first and the third are fair. So the distribution has to go in a way that is optimal for everyone. So a lot of you are getting hung up on the divider chooser method because you're like, well, that doesn't make sense. Why do we want to get that? It doesn't make sense. Well, this one makes a little bit more sense because we're doing optimal distribution. So for Dale, S2, he's going to get it because nobody else considers that to be fair but him at 33.3 repeating percent. Cindy gets S3. She values that the most, so she's going to get it, even though her S1 and S2 are fair to her. It makes more sense. She likes that one more, and Claire likes S1 more, so she's going to get the S1, right? She likes it more than Claire, and then, no, I'm sorry. She likes it more than Cindy, and Cindy likes S3 more than Claire. So they kind of divide it off in that particular instance. Now, that is optimal distribution. Okay, that is whenever we see optimal distribution for that. Um, if possible, you can fill this in underneath. If possible, players will receive the more preferred fair share, but it's still okay with anything that is considered to be fair. So even though we gave Cindy S3 and Claire S1, they both would have been okay with getting the other piece of land. Flip flop. Case two is if there's a conflict. So choosers can only receive the same fair share. Okay, this is a conflict. So the divider gets a share that is unfair to both choosers because there's three people here. So the divider cuts it, and the one that's unfair to both choosers is going to go to the divider. If possible, last preferred. The remaining shares are reconnected, and the two choosers will perform what we learned last time in the divider chooser method on this new combined goods. So the divider cuts it all off, right? They're like, well, this is my least preferred. So the divider gets that, whatever's the least preferred, probably to both of them. And then the two choosers now have to do what we learned in our last method, which is the divider chooser method. So according to both chooser 1 and chooser 2, remaining value is greater than 2/3, and both chooser 1 and chooser 2 will receive a share that is greater than 1/3 in their opinion. So now we've got another case. This is going to be for the conflict, and it says that three siblings are dividing a pie their grandmother baked for them. Determine which piece each sibling will receive. So same Dale, Cindy, Claire scenario. And Dale is the knucklehead who cut it all up, and he can't cut according to his two sisters at all. And they don't like the way he cut that pie. Dale's looking at it and he's like, well, you know what? That's good. I like every single piece of that pie. I'm good with whatever I chose because maybe he knows something they don't about the way that he cut it. But Cindy and Claire, they have their own opinion. So for them, what we're going to notice is that the bid list, again, is that Dale likes all of them. Remember, bid list means the ones they consider to be fair. So Dale likes all of them. Cindy and Claire both only like S3. They only think S3 is fair because it's greater than 1/3. So the conflict is Cindy and Claire only will be happy with S3 and no other shares. So Dale is going to get S1. Why does Dale get S1? Because both Cindy and Claire say that that is the least preferred to them. For Cindy, it's 20%, which is the lowest percentage. For Claire, it's 10, which again is the lowest percentage. So now Dale gets that S1 piece, and they're both left with S2 and S3, or the second cut and the third cut. So how much is the new combined goods valued to Cindy and Claire? Well, Cindy is 30 plus 50, which is 80%, and Claire is 20 plus 70, which is 90%. So because both of those are greater than 60%, when we make right now our assumptions, now when we do a divider chooser, they're going to have to choose the correct one. So what is the maximum amount each one would receive in the divider chooser method? So if we were to cut it in half, right, take those pieces, somehow we put them back together, and now we do a cut, half of that cut of half of that 80 for Cindy is 40%, and half of that will be 45% of the original S1 and S2. So that's how that distribution is going to work. So the loner divider with more than 3 players, now we're not necessarily worried about it, but we can make a cut. We didn't decide who it was going to be, but that's the maximum that each one will get. So don't worry too much yet. So the loner divider with more than 3 players, doesn't matter how many it is, you've got to assign who the players are. One person's the divider, and then everybody else is a chooser. So the division is in fair ways. So basically, if we want to be fair and we got 5 players, it's a fifth. If we want to be fair and it's 6 players, it's a sixth because it's over the number of players or pieces. So the bid lists from now on are from all the choosers. So whatever they decide to be fair. The distribution compares the choosers' bid lists. So for case number 1, all choosers value a different share. So each chooser gets a fair share and divider gets the remaining piece. Look at case number 3. We've got 4 people. We got Annie, Beth, Claire, and Destiny. And here are their cuts of whatever they decide, whatever they cut, whatever the goods were. And so looking at Annie, we can see Annie likes 40%, 20%, 20%, 20%. So the only one, right, if we're doing a fourth, because a fourth would be fair share to Annie, 1/4 is fair. A fourth is equal to 25%. So she doesn't consider any of these to be fair because, in her opinion, the only one she considers to be fair is S1. So that would be her bid list. I want S1. That's what I want. So for Beth, she considers all of them to be fair. So her bid list is S1 through S4, every piece. Claire says, okay, well, S1 I don't like because it's not 25% or more. She likes S2, she likes S3, but she doesn't like S4 because it's less than 25%. So Claire's is S2 and S3, and Destiny's is going to be S2 and S3 as well. So she likes those two. So S1 and S4 don't care. So the distribution is going to need to go, Annie gets S1 because that's the only one Annie could take. She can't be fair for the rest of them. Annie has to take S1. Beth takes S4 because she likes all of them. Well, let's distribute accordingly. So if we're looking at Claire and Destiny, see how they both like S2 and S3? Well, Destiny likes S2 more, or excuse me, S3 more, so Destiny's going to get S3. Claire likes S2 more, so she's going to get S2. And then Beth is left over with whatever because she's okay with getting anything. So in that case, there was no conflict. We were able to optimally or fairly divide them all off where everybody's happy with what they get. Now, in this case, there could be a conflict. Let me get rid of this right here. There could be a conflict in this case. There are more choosers than items they think are fair to bid in those lists. So like 2 choosers, 1 piece, 3 choosers, 1 piece, or 2 pieces. So basically, you got more choosers than what we can divide off. So there's 2 choosers that only like 1 piece. There's a conflict. So if there's 3 choosers that only like 2 pieces together, there's a conflict, right? Because somebody has to not get what they want. So if there's non-conflict choosers get one of the fair shares that they decide. The divider gets an unfair share of all of the conflicted choosers, even though the divider, because they're the divider, they're going to get what they like. And the conflicted choosers combine remaining shares and repeat the method between them. So example 4, this is a case where we have a conflict. We've got Marcus as the divider, Aaron, Kim, and Amy are choosers. So Marcus cuts it. He's happy with what he cuts because he gets fair. So if I go back up here before, wouldn't it make sense that Beth was the divider because Beth cut it all evenly? Right? The person who cut it and it's fair for every piece, that's always, let's rephrase that, it's always going to be the divider. So Marcus is the divider. Everything's fair to Marcus. Notice that the only thing that's fair to Aaron is S4. The only thing that's fair to Kim is S4. And Amy's okay with S2 and S3. So the bid lists go that Marcus is good with everything. Aaron only likes S4. Amy's good with S2 and S3. And Kim is only good with S4. So here's how we distribute to begin with, because we're going to have to do it again, right? We're going to have to redo. Amy's going to get S2. Marcus is going to get S3. Why? Because Amy likes S2 the most out of hers, and nobody cares about S2 besides maybe Marcus. So Amy gets that one. That's the one you like the most. The other two don't care about it. You can have it. Marcus is going to get S3 because it's the least valued between Aaron and Kim. Aaron values S3 at 20. Kim values S3 at 20. So nobody really cares that Marcus gets it besides Marcus. Maybe Amy liked it, but Marcus gets it because the two people who don't want it, right, who have the conflict, they don't want that at all. So Kim is going to have 28.5% of the original, and Aaron is going to have 30% of the original. So where do we get those numbers? Okay. So look at what's left and then divide it by 2. Okay. Look at what's left. So what they're doing is they're taking the two pieces that were left over and they're dividing it in half, and you get this piece and you get this piece, right? You get both parts. So like this, Kim had 22% because S1 was left on the board and S4 is left on the board. So for Kim, that's 22 plus 35. So 22 plus 35, that's going to give us 57. And then we divide that in half. So she's going to get a piece of both of those. And that's where we get our 28.5%. For Aaron, that's 30% of the original. Again, Aaron, S1 plus S2. So S1 is 20, S2 is 40. That gives us 80%. And then divide that, 60%. Brain fart moment there, 60%, and then divide it by 2. And so from the two amounts that were left, they cut it in half and give it away, right? It doesn't, in this case, I don't even know what it was. Maybe it's a piece of cake, maybe it's land. I don't know. But they're going to get a piece of both pieces of land because they value both of them. They're just making it hard on everybody. So 30 in that, they get 30%. So that's how we got that 30%. That's how we got our 28.5%.